Okay. Well, good afternoon, class. Today we're going to begin our journey through logarithms. Well, I guess I could say our ordeal known as logarithms.
Actually, you'll be impressed with what you can do by the end of class. And the last time we looked at rules of exponents, and the reason we were working with exponents is because logarithms are exponents. If someone asked you what is a logarithm, the easiest, most straightforward answer would be a logarithm is an exponent. So I'm going to state the definition of logarithm. L-O-G, log, and this is a subscript. Log base b of x equals y means b to the y power is x.
Notice b has the same restriction as a base for an exponential function. That means b has to be a positive number, but it can't equal 1. But make a note, b is positive, but not 1.
Okay, so a logarithm base is a positive number, but not 1. We'll assume that every time we see the letter b used as a base. You'll notice with the exponents, we call the small thing up here an exponent, and this is b is the base. When we write it with logarithms, the small thing, the subscript is the base. The exponent is written a normal size. Let's look at an example. Try to figure out this. Oops. Let me write it down neater. Try to figure out this logarithm. Log base 5 of 25. The small number here is the base. What you're thinking to yourself is, this number over here is the exponent. What exponent do we put on 5 in order to get 25? 2, okay? The answer here would be 2, and let's write out why. 5 to what power gives 25? A 2. Now, here's a tricky one. It's going to involve something that we said the last time. Log base, let's use base 7 of the number 1. What's log base 7 of 1? Here's what you're thinking. You're thinking, what exponent do you put on a 7 in order to get a 1? And it goes back to something we did on 0. Did y'all hear that? 0. Let's look back at those exponent properties right here. A to the 0 power is 1. Okay, so 7 to the 0 power would be 1. Now, is there anything special about 7? If I change the 7 to a 4, would the answer still be 0? Yes, and so here's a rule of logarithms. It's always true. Log base b of 1 is always 0. It doesn't matter what that base is. If the number after the base is a 1, that logarithm's going to be 0. Logarithms are exponents. B to the 0 equals 1. Okay. Now, the next one I'm going to state, it's going to seem difficult, and sometimes things can be difficult just because they're so easy. The answer's staring you in the face, but it looks terrible. Log base b of b to the x. think in terms of exponents. What exponent do I put on the small b here in order to get b to the x? X. B to the x is b to the x. That is actually an important rule of logarithms, and I've actually seen this statement as the definition of a logarithm in some older math books. What is it saying? Well, do y'all remember, what do we call two functions that cancel each other out? Like multiplying by 3 and dividing by 3. Starts with an I. We did inverse, is that what I heard? Yeah. Logarithms and the logarithmic functions and exponential functions are inverses of each other. When you look at it like this, if you have the small base and the big base, if those are the same thing, they cancel each other out. Okay? If you have the same number here and here, they cancel each other out. Another way to state it, which doesn't look quite as obvious, is if you write the big B first.
Remember, if they're inverses, they cancel each other out regardless of the order in which they're performed. So it doesn't matter what the inner function and outer function are. As long as they're performed consecutively in either order, they cancel each other out.
And those two rules right there we're going to use to work or to solve some logarithmic equations. But before we do anything, I need to give y'all some notation, because at any point in the assignment it might pop up. If you just see log without a base, we assume that's log base 10. So if you see log and there's not a little base stated, okay, it's log base 10. And that's called the common logarithm, or the common log. So if anyone talks about common log, it's log base 10. And then there's another logarithm that y'all might not like very much. It's denoted Ln, okay, and I'm writing it with a capital L, but when we're typing this stuff in Pearson, you never use capital letters. So I'm going to go ahead and write it now with the lowercase cursive L, so it doesn't look like a capital I.
You cannot imagine how many emails we get each semester, not just from college algebra classes, but from math for business classes and business calculus classes, any class that uses natural logarithms, and they want to know why they're getting counted wrong. They're typing in a capital I in. Logarithm begins with the letter L. The notation for every logarithm begins with the letter L. So
never use a capital letter when typing anything into Pearson MyLab. If you keep in mind that you cannot have a capital letter, then there's no way you can be typing in a capital I. Lowercase Ln. The last time we discussed this little decimal number, 2.71828182846, I think it is. It's denoted with a lowercase letter e. That's what Ln stands for. It's log base 2.71828. Y'all aren't going to do anything with that 2.71828, but the Ln's will pop up.
Realize how they came up with that notation. This is called, log base e is called the natural logarithm. They wanted logarithm to start with the letter L, the notation, and so they just decided to reverse the initials, Ln,
rather than NL. I think if they used NL, well, there'd still be people putting N and capital I.
Probably.
Maybe not.
I don't know.
Okay. So, and I'm telling y'all this notation just because eventually they're going to start popping up. I'm hoping it's not on the first problem, but let's see. We're going to do problem number 1. and we're going to be solving some logarithmic equations.
This is sort of exciting, Tony, because I really take a different approach to introducing
Okay.
this.
It says solve this logarithmic equation. X equals log base 2 of 1 over 16. These two rules right here.
You've written it down.
Okay. These two rules right here are the ones that I'm going to use to solve a logarithmic equation. When the instructions say solve for x. When we're solving equations, we just want x equals a number. Here we have x equals log, all of that stuff. So we need to somehow or another get rid of this log base 2. We just want a number. We don't want the log. So what you're going to do is something that we were doing in the class the last time with solving exponential equations. We're going to try to get the same base. If we can rewrite this log base 2 with the same base here and here, then they'll cancel out. So I'm trying to cancel out this log base 2. I'm going to rewrite the 1 over 16 with just a base of 2. Why 2? Because that's what this number is right here. If the small base had been a 3, I'd be trying to rewrite it with a 3, which would be impossible. Now, how many 2's do we have to multiply together to get 16? 4. Now, here's something. I wonder if y'all remember. What do we do to get rid of a 1 over? What am I going to do to that 4 to get rid of that 1 over? Put a negative on it. Okay? And that was this rule right here. A to the negative n equals 1 over a to the n. To get rid of a 1 over, make the exponent negative. Now that we have the same number here and here, I'm using the blue star rule, which says if you have the same bases there, all of that gets canceled out. I'll use it. And we have x equals, what is it? Negative 4. X equals negative 4 is our solution.
2 to the negative 4 power is equal to 1/16. In terms of the definition,
Type it in.
Yeah, I was about to say if you could drop that down.
Negative 4.
Okay.
Go back to what?
Oh, the page so we can finish writing it down.
Well,
There.
that next one.
So I'm rewriting this so that I have the same small base and big base. Because if you have the same small base and big base, they cancel each other out. Whether it's written with the logarithm first or the big base first. Okay?
Number 2.
2. X equals log base 6 of the 4th root of 216. Since we have a radical here, that little symbol, the red symbol there. Oh. Since we have that radical, let's go back and look back at the rules that we had about radicals the last time. The definition of a fractional exponent. A 1 over n power means nth root. But if you have something other than 1 on top, the m over n power, the m, the top number is the power, the bottom number is the root. Top number power, bottom number root. On this one, I just want x, like number 1, I just want x equals a number. I don't want all this logarithm stuff there. So what I'm going to need to do is rewrite this stuff here with the same base, a 6. How am I going to write the 4th root of 216 using a base of 6? Well, let's take care of the 4th root first. The 4th root puts a 4 in the bottom there. Looking back over here, the bottom number on the exponent is the root. Now, what about the power? Get your calculator. How many 6's do we need to multiply together to get 216? Go 6 times 6.
That's just 30.
30.
Oh, what's happened? Okay, hold on. I have to read. That happens. Let's see. Let me try it again. There. Okay. 6 times 6 is obviously just 36. But if we multiply it by another 6, 6 cubed, sure enough, we're getting 216. And I'll tell you this much right now. You have to be able to get that common base. Otherwise, it's an irrational number.
And we'll have another
method of solving those equations where you can't get, it's impossible to get a common base. But for the time being, the only method you have is to get that common base.
The small base and the large base are the same. You just cancel all of that out. And you're left just with x equals 3 over 4. I know this is very different from other stuff you've done unless you've worked with logarithms before. Okay?
Can I show something? I won't write it here and mess up your notes. Okay. As I said, Tony and I take a different approach to introducing this stuff. And so, here's what I would have done. And this is the last time I'll interfere with his class, okay? Oh, well, x equals. I would have split it into 2, rather than doing the way Tony went directly to 3/4. I would have said, okay, the first thing I'm going to do is rewrite that 4th root. I'd rewrite that 4th root as an exponent of 1/4. And then I would have said, okay, 216. That's 6 times 6 times 6. So I'd have log base 6 of 6 cubed to the 1/4. And then I would have said, power raised to a power. We have a property of exponents somewhere along the way. Power raised to a power, what do? Multiply 3 times 1/4. 3 times 1/4 gives me the 3/4. So I would have gone, rather than using the m over n property, I would have split it up using... I think that the fewer steps is better here. The top number is the power, the bottom number is the root. Now what about problem number 3? We have to patch in the answer.
Oh, okay.
So that would be 3/4. Okay. Next. Okay. Oh, I like this one. If you recall one of those properties, that's right.
Because you said that because it's 4 with an exponent of log 4, does cancel out both the 4s, so the answer is 10.
As long as they're consecutively, written consecutively, they cancel each other out. Where's that property? Here it is, right here. You've stated it right there. If the base of the exponent is equal to the base of the logarithm, they cancel themselves out, leaving us whatever that stuff was there. And in this case...
So there's not a lot of work here. It looks like all I'm doing is just writing down the problem and writing the answer on this one.
And that's right. That's what
you want to do work, you can cancel out those.
Because technically the answer is given to us.
I remember the first time I ever saw this as a student, I thought, yeah, wait a minute. What would happen if the 4 were a 3? What if these two numbers weren't the same? There's no logical reason why that would ever happen. You might write it down, but there's no logical reason why it would happen.
That you're going to see later on as we go further in and we're solving more advanced logarithmic equations, what we're going to be doing is we're going to be asking ourselves, what base do we use to cancel out a log 4? If it's a log base 4, you use the base of 4.
In fact, I think number 4 hints at it.
Let's see.
So let's type. Oh, you've already done it.
I did,
Okay.
yeah.
Number 4.
I got to say, I'm just having the time of my life doing this. It's so exciting being back in class after 2.5 years. I don't know how y'all are enjoying it, but I'm just loving it.
Well, how does number 4 physically differ from 1, 2, and 3? It has the same instructions about solving the equation. But on problem 1, 2, and 3, the x is by itself. The x is already isolated. Here, the x is not isolated.
So we minus x from both.
No, it's not. A minus isn't going to cancel out. Let me look back at this. We have a logarithm. Like right here, looking at this one here, if we have the same big number here and here, the same base, they'll cancel out. All I want is this x. I want to cancel out that log base 5. I'll give you the hint. What big number could I put right here? When I say big, I mean I'm writing it large in size, not as an exponent, okay?
5.
Yeah, if I put a 5 right there,
Then
and
you got to put
there.
it on the other side too. You just turned the original problem. The original problem has just been turned into exponents with a base of 5.
No, so why is it sensible to say you'll always have the same number here and here? When I was a student and I worried, well, what happens if there's a 3 and a 4, they don't have the same base? You're deciding. Why would you put any number other than a 5 right here? Whatever this base is, you put it there. It cancels out, leaving just an x on the left. Now, don't say 10. The right-hand side, let me write it a little neater. It's 5 to the power of 2. So 5 squared, 25.
Once again, that's not how I would have done that problem, but I'm not sure that your method isn't growing on me. Yeah.
25. You want to
Oh,
type
I
it
bet
in
I'm
just
just
to
sitting
convince
here.
them that it's
Okay.
right?
This isn't how I would have approached that problem, but I like it.
Do everything based on the fact that exponential functions and logarithmic functions are inverses.
So what we're supposed to do is just replace x with the equal formation.
You want your answer x equals a number.
Can you
Click similar. Let's do one more.
Okay.
Oh, and
I like this one.
Oh, you do, even though there's too many 3s?
Yes.
27, right?
Oh, well. Okay, I'm going to do some color coding. Log base 3
The answer is
of
27.
x, yeah,
Okay, yeah, I figured out the code for it.
equals 3. Log base 3 of x equals 3.
You want to cancel that log base 3,
Put a big
so you use this black
You're
3.
using the black 3. That's the reason you're putting a 3, not the red one. Put a black 3 on both sides.
So it's x equals 3 cubed, which equals 27.
X
I figured out
equals
3
3
cubed,
cubed. You can say it faster than I can write it.
which equals 2.
And 3 cubed is not 9. It's 3 times 3 times 3,
27.
27.
Okay, I figured out how to do it to make it easier for some people.
Just that to that. Yeah, that's the definition. Isn't that
That's how
how
I
I
would
defined
understand
it?
So pretty much
This raised to this is
pretty much
that.
have the small, the one next to the log as the x. No, have the big as the exponent to the small.
That's exactly
That's
right.
how I
That's the
define that.
definition.
B to this power equals that number. Okay? Okay. But eventually we're going to have some that are more involved, and that wouldn't not,
Yeah.
and this method will always work. Now, I want y'all to see problem number 5 before you start panicking. And just so you have an idea of what's ahead of you, in a moment, you're going to be able to do this problem in one step. Okay? But let's leave that alone for a while.
I wanted to show you, we're putting in instructor tips here. Never type capital letters or hit the space key. If you're typing it in correctly, each logarithm will automatically bold. Logarithms always need to begin with a lowercase l, and we even spell it out, E-L, not a capital I. E-Y-E. Oh.
You have no idea. Even this,
I wanted
at this
to show
point
also,
in the semester, I've already sent dozens of emails to my business math students with that same statement, wanting to know why is it counting it wrong. They're typing a capital I instead of a lowercase l. Never, ever, ever type a capital anything
in my lab.
in my lab. Okay?
Oh, but I want to point out to you, number 5 is multiple choice, but then you're going to have to start typing the stuff in yourself, okay? So you'll be using that subscript hot button that we haven't. We've used the superscript, the exponent hot button, but we have not used the subscript. And so here.
Now, there are 3 rules of logarithms that are so important they have a name. The first one is called the product rule, and it looks like this. Log base b of m times n. I'm going to put a dot to indicate multiplication. Log base b of m times n can be rewritten log base b of m plus log base b of n. Formally, we could say the log of a product is the sum of the 2 logarithms. Okay? That rule comes because of this first rule over here.
Here's the product rule of exponents. With the product rule of exponents, when you're multiplying bases, move your finger, Tony. When you're multiplying bases, the bases are being multiplied. What do you do to the exponents? You add the exponents, m plus n. That's the product rule of exponents. So when you're multiplying the base, add the powers. Let's look at the product rule of logarithms, Tony. You're multiplying. This thing here that follows the logarithm is called the argument. So you're multiplying those factors in the argument. You add the individual logarithms. Tony, before you state the quotient rule, we'll start writing it out first. I have a fun idea.
Quotient means division, just like product means multiplication. Log base b, I'm going to write the division as a fraction, m over n.
Okay, don't write it. I'm going to go back to the quotient rule of exponents and see if they can figure out what this is going to be.
Well, what I normally tell them is, if you rewrite multiplication as addition,
It's going to be subtraction.
yes.
Look back at that.
Yes.
Look right
The
here.
second rule here, when we're dividing like bases,
There's a
you
strange
subtract
symmetry.
the exponents.
Notice that strange symmetry between the rules of exponents and the rules of logarithms. And that's because logarithms are just fancy ways of expressing exponents. With the quotient rule of exponents, when you're when you're dividing the bases, you subtract the powers. Dividing the bases, subtract the exponents. Over here, dividing the argument, subtract the logarithms.
Wait, can you turn to that?
Oh.
That's good.
Oh, you want to look back at this one?
Yeah, because remember I wasn't here for the whole conference, so I wasn't able to like write that down.
Oh, okay.
Thank you.
A to the m over a to the n, or b if you want to use a b for base. Maybe that would be better. I use a. When looking at exponents, I use b once I start logarithms.
I'm going to do that up now. Jacob, it just now dawned on me, I forgot to, we had scanned all these notes, and I was going to upload them to files under on Canvas, and so you don't need to write these down. I'm about to go and upload them right now to files under Canvas, so you'll have this, and I even scanned it in color, so.
I was able to write it down.
Okay,
Okay.
go back.
So the quotient rule says log of a quotient is the difference of two logarithms. And finally, one more rule, the power rule. Log base b of m raised, I'm going to use a lowercase n on this, raised to the nth power. I think maybe I'll do this. Okay. Log base b of m to the n. If you have an exponent at the end of a logarithm, you can move that exponent down in front of the letter L and write it as n times log base b of m. If you have an exponent at the end of a logarithm, you can move that down in front of the letter L. Okay? What we're going to start doing is expanding logarithms. By that I mean, and it's going to sound worse, but give yourself 20 minutes and you're going to think it's easy. In 20 minutes you'll be able to do this problem pretty much in your head. Okay? And you'll be able to just call out the answer to number 6 for me, okay? But, so don't panic.
I'm going to vote for
Oh, are you ready to panic?
I'm all right. I'm in a constant state of panic.
Oh, okay. Well, try not to, but we will expand logarithms using the product rule, quotient rule, and power rule. Okay, and I'm going to show some steps. I'm going to take a logarithm and do what's called expand it, and I'm going to go through some steps, and the order of the steps that I'm going to go, it'll be in this order. The first thing I'll do is use the quotient rule. The second step, I'm going to use the product rule. So the first thing I'm going to do is rewrite the logarithm so that I have, no fraction. Okay, I'll rewrite the fraction as subtraction. I'm then going to rewrite multiplication as addition. The third step, I'm going to wait and see if y'all can figure it out when we get to that step.
Use the power rule.
That's the fourth step. And I'll come back over here and fill in the third step in a moment. Okay? I'm going to go through this stuff showing steps step by step by step. And I'm glad Tim's not in here because I don't want to hear him, let him hear me giving him credit. But I remember years ago when my brother said, "Oh, wow, if you don't make the students show steps on expanding logarithms, it's a lot easier for them." And I said, "No." And he said, "Go into the class and do it without showing any steps." And I said, "Tim, that's crazy." And he said, "Just do it." And I went in there and, oh my gosh, teaching logarithms went from being my dreaded topic to my favorite topic. Okay? So only one time am I going to go through a lot of steps. If you're a view and example kind of person, they're going to be showing a whole lot of steps for stuff that you'll be able to do in just one step. Okay? So first thing we're going to do.
Just one step.
Oh. Okay. Mm-hmm. So we're going to be taking one complicated logarithm and rewriting it as several smaller logarithms. Okay? That's what we mean by expanding the logarithms. And the first example, I'm just going to make up and will hopefully
just one easy step.
Eventually example. But the instructions in my lab will either say something like expand the logarithm, or it might say something like use the properties, and that's what they mean by quotient rule, power rule, and product rule. Use the properties of logarithms to write as a sum or difference. So here's log base 7 of a to the 1/2 power, b to the 3rd power, all over c squared d. So we're going to expand this logarithm. By that I mean we're going to write it as a lot of just small logarithms rather than all that big messy stuff after the logarithm. The order in which we do this, we start off with the quotient rule. The quotient rule says you can break it up as top and bottom. Log top minus log bottom. So this is the quotient rule I'm doing right now. Log base 7 of the top, then a minus log base 7 of c squared d. So that's the quotient rule. It says log top minus log bottom. Okay? Now I'm going to use the product rule, and I guess I should have said use the product rule twice. You're going to use it here. Right here there's multiplication. So I'm putting the red dots just to show that's where the multiplication is. And so the product rule, you write log first factor, then a plus log second factor. I'm going to have to start writing a little smaller. So in place of this, I put log base 7 of a to the 1/2, then a plus log base 7 of b to the 3rd. So I'm going to put there. This stuff with the green parentheses around it, you may not be able to tell that's green ink, is this first logarithm. Our goal is to get smaller and smaller stuff after the logarithm. Okay, we started off with 4 variables after the logarithm. We're now down to 2 variables here. Right here, we're down to just 1 variable after each logarithm. Then this red minus is that one. Do the exact same thing with this. Okay, did y'all hear that? Log base 7 of c squared plus log base 7 of d. So we've used the quotient rule. We used the product rule. I said there's a third step that I didn't write here. Now it's time to figure out that third step. No, I'll give you a hint. It has something to do with this minus in front of the parentheses. What do you do when you have a minus in front of a parentheses?
Multiply.
No, I'm looking for an answer to start with a D. You distribute this minus. It's going to change the signs. That's the third step. Distribute the minus. So I'm going to distribute the minus. You might be thinking it seems hard to believe you'll be able to do this problem without any work in a moment. Okay?
Without any work.
Just type out the answer. So I'm writing it without those parentheses. Log base 7 of a to the 1/2 plus log base 7 of b to the 3rd. Now distributing the minus, it's going to be minus
log base 7 c squared minus log base 7b.
Okay. So that was the step of distributing the minus. Which rule have we not used yet?
Power rule.
Yeah, that power rule. The power rule says if you have an exponent at the end of the logarithm, you can move it in front of the L. So move the exponent in front of the letter L.
So would that be log would be the exponent or no?
No, the 1/2.
So
Take the 1/2, move it in front of the letter L. So it'd be
1/2 times log base 7a plus 3 log base 7b minus 2 log base 7c minus log base 7b.
Okay. Now, a natural question is, or based on what I've said to y'all, I keep saying you can do it in one step without showing these steps. Do y'all see the pattern? How will you go from here to right here? Let me show you.
Yeah, I can kind of see it.
Okay, going from here to here. Separate logs at multiplication and division. Let's go ahead and say not at addition or subtraction. If we look at this original problem, I'm going to put the red dots wherever there's multiplication. That would be here. Where else is something being multiplied? Right here. And then there's the division. You separate at multiplication and division. So if I separate here 1, 2, 3, 4, it's going to separate into 4 logarithms. Okay? The exponents go where? Looking at this and the final answer. The exponents go in front of the letter L. There's no exponent on the D, so you don't put a number in front of the letter L. Now look at the signs, the pluses and minus. The stuff up on top, those are positive, you see, plus. But to really get the pattern, the stuff on the bottom has what sign? Plus or minus in front of it? Minus. So to separate them, you separate them at multiplication and division.
Or you could just put things below or the things on the denominator.
The stuff that's below that's on the bottom of the fraction in the denominator, that has minuses in front of them. The exponents go in front of the letter L. Let's expand a logarithm without showing any of those steps. That's the only time I'm going to show those steps. And let's make this a real doozy. Expand log base 3 of x to the 1/4, y to the 5th, w to the 2/3 over 9, just the number 9. Oh, not yet. A to the 4th and b squared. And change that 9 to an 8. I think it'll be a better example if that's an 8 there. Okay. So this is doing it the way my brothers told me that students like to do it years ago, and I thought he was insane. Separate at multiplication and division. Go through and put red dots everywhere there's multiplication. Well, here, 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 here. And I'm going to even sort of write the fraction bar in red, because that's where it separates. How many logarithms are we going to have once we expand it?
How many distinct factors do you have on top? First, there are 3 on top. What about on the bottom? 3 as well. Realize the 8 and the A are not together. It's 8 times A times B. So I agree, there are 6 distinct factors, so you need 6 distinct logarithms.
How many minus signs am I going to have in the answer?
3.
3. Okay? To get started, the exponent. Now, I'm just going to start writing it out. Okay? I remember one time when a student told me, it looks like you're just writing the problem down and writing out the answer. And I said, yeah, that's what I'm doing. Okay? Write the exponent first, then log base 3 of x. The y is on top. I'm moving on to the y now, so I'll put a plus. Exponent log base 3 of y. Then the w is on top, so another plus. 2/3 log base 3 of w. Now we're going to the bottom. The 8's on the bottom, so we're not going to put a plus. We'll put a minus.
And realize once you switch to a minus in an expansion, you do not go back up to a plus. All the rest of them logarithms are going to be preceded by a minus because all those factors are down in the denominator.
Now, notice there's not an exponent on the 8. So you don't put a number in front of the letter L. You just write minus log base 3 of 8. Oh, I wish my paper were, oh, that's a stupid wish. But if my paper were longer, I'd just keep right on writing. But instead, I'm just going to carry right on over here, move on to a to the 4th. It'll be a minus, because the a's on the bottom. There's an exponent, so 4 log base 3 of a. And who wants to tell me the last term I'm going to write? Plus or minus?
Minus 2 log base 3b.
Okay. I remember the time a wonderful student said to me, "Oh, wow, it takes longer to type these answers in than it does to do the problem." Yeah, that's going to be a problem, typing them in. Okay?
I think they're ready to start doing some examples.
I think they are. So let's do number 5.
Oh, by the way, I uploaded the class notes, PDFs of all the class notes. We'd already uploaded some of them, okay, but the most recent lessons over inverse functions, zeros, and polynomials, and I put an announcement on Canvas under announcement with the link to those PDFs if you want to see our handwritten notes for each class.
So log base 5 of square root of x, 7th root of y. Oh, wow.
Oh, wow. Look closely. Look closely. Let's see. What does it? I'm going to blow this up a minute. Let's see this. No, that's not it. What is it that does it?
Is it Control Shift Plus? Is that good?
Yeah.
Oh, that helps a lot.
Doesn't it? Forget it.
What? This?
Okay, there. Notice this 7 here. It's right above that little hook on this radical. So that's saying the 7th root. Look down here. Is this thing saying a cube root of z? You have to look closely. Is that 3 right above the hook on this radical? No. So that's just a w cube there. This thing here is just back to square root. You've got to add this to your bag of tricks when working with logarithms. If your logarithm contains radicals, you need to rewrite those radicals in terms of exponents. Logarithms are just fancy ways of expressing exponents, so it shouldn't be a surprise that when you run into a radical like radicals like this, you need to write them using an exponent. So let's switch back.
What's he saying? Remember the way nth roots are 1 over n powers. A cube root is a 1/3 power. A square root, what exponent will I use for this?
1/2.
Yeah, so there is one step that we have to do here before we can just start writing out the answer. And that's
Write these things in terms of exponents. But once you have them in terms of exponents, you'll be able to go to the expansion without showing any other work. What exponent are we going to put on this x here?
1/2.
Well, okay, you already answered that. What about the y? We have a 7th root, okay?
And the z would also be 1/2. So
That's right.
it's the same as
How many distinct logarithms are we going to have in this expansion? How many distinct factors do we have?
4.
Okay, we have 2 on top, 2 on the bottom, so I agree with 4
2 of them would
logarithms.
be negative.
I remember years ago a sweet student saying to me, "You seem to think those red dots are important, and I don't know why you're doing that." And I said, yes, they are important. That's where we separate. 1, 2, 3, 4. You separate at multiplication and division, not at addition or subtraction. So we're going to have 4 logarithms and 2 minuses. And you start off, what's the first thing I'll write?
1/2
1/2
of log base 5 of x
log base 5 of x plus or minus.
plus
Mhm.
1/7 log base 5 of y.
And that's a plus because y is up on top, but we're about to move down to the bottom. So
Minus
Minus
3 log base 5w minus 1/2 log base 5 of z.
Here. Okay. And this one is multiple choice. The rest of them are not multiple choice. Okay? But there's a reason why I've assigned a multiple choice one here. Okay. Oh, look through them all closely.
Well, it's not D.
Oh, go back.
It's C. You're saying it's not D. Well, I know for a fact it's not A because it has the top ones as negative when they're not supposed to be.
Okay.
And it can't be D because it doesn't have the things out front, so the only answer is C.
Hopefully answer C looks like this, like what I've written or circled there. Okay, and it is C, but what's interesting here is that that answer D. This cannot be simplified. I'm going to check and make sure it's right, and switch over here. Okay. I'll say expand if possible. Here's a logarithm for us to try to expand. Log base 2 of x squared plus y cubed minus z to the fourth. Just like on that multiple choice, there was that option, it cannot be simplified. That student that time that said to me, you seem to think putting those red dots are important, and I don't see why that matters. Well, can I separate this? You separate at multiplication and division, not at addition or subtraction. So, can I put any red dots here? Is there any multiplication or division? No. This one can't be expanded. You can't separate it. What do y'all think the common wrong answer would be? Separating it at the plus and the minus? But that'd be wrong. You separate at multiplication and addition. Excuse me, and division.
I want to make a note here, okay? I think this is important. Note, log base b of m plus n, I should say plus or minus n, cannot be expanded or simplified, whatever you want to call
Separated.
it. It can't be separated. That's a good word.
Mm-hmm. Now, I think we're ready to start doing some of these where we're just...
You're going to have to type the answers in.
Oh, go back. He's still running the sentence.
Oh, wait. Hold on. There. The log of a sum or difference cannot be separated.
Or expanded, or
Or
however you want to write it.
Okay. Number 6, I want y'all to call it out to me. How am I going to type this in? How many distinct logarithms am I going to have in my expansion? How many distinct factors are there? There's 2 on top, x and y, and 1 on the bottom, z. I agree.
How many minus signs is he going to have in his answer?
1, the
Okay.
one preceding the z. And with that in mind, start calling it out. I'm typing it in as you call it out.
Do not hit space keys, and do not ever use a capital letter.
Okay? What will I type first?
I'll get them going. 2.
2, and then okay, notice what I'm about to do. I'm going to write log, type it in lowercase. L-O, look what's about to happen when I type this G. It bolded it and spaced it correctly. And then I need my subscript B. So we've used the superscript button. Now with exponents, this is the first time we're going to be using the subscript button. You see the subscript button down here in the box? You click it. What do you type down there in that blue box?
B.
A B. Then do a right arrow to get out of there. X.
Then do
Plus. I agree it's a plus because
log.
we're still on the top.
Now, Tim, let's do this. If I type capital L-O, if I'm doing it correctly, it should bold. No, it didn't
did
bold.
not.
Look at this. Is it going to bold now? Why did it not bold?
This is capital I.
I put a capital I instead of an L. You have no idea how many emails we get, especially from our online students.
There's no capital letters.
Oh, they want to know, how do they bold it? They can't bold it. You don't do anything to bold it except type it in correctly. It'll bold automatically.
You don't capitalize anything in math.
Well, what about the what comes after that Y?
Minus,
Because we're moving down to the denominator.
minus 5.
5, because the 5 is the power, it becomes a coefficient. And then log. Notice how it bolded in space so nicely. Right arrow to C. Right? Oh, let's see. Check it.
Any questions
there?
You know what? The natural question in math, we always do it one way, and then what do we do? The other way. Could y'all go backwards?
Yes.
How would you go backwards?
There are 3 logarithms. Suppose you want to, it's taking multiple logarithms and going backwards to a single logarithm is called condensing. I always look and ask myself, do I need a fraction bar? If I'm going to condense, the first question I ask myself is, will I need a fraction bar here? And you can tell you need a fraction bar because of what? That minus sign. And then the arguments that have positive coefficients go on top. Any that have a negative coefficient goes on the bottom. The common mistake when going backwards, people want to put a plus right between the x squared and the y. No, no, no. You don't separate logarithms at addition or subtraction. Okay? But we'll get to that in a moment. We still have
more of these. Don't use capital I.
Not that it ever helps.
Oh, okay.
Okay.
Number 7. This one, I'm going to write a little bit before we just type it in.
Where's the log base?
Okay. Oh, that makes it easier to type in. Notice,
Right.
we finally got to one where there wasn't a base stated. And if there's not a base, it's log base 10. So that just makes it easier to type in. Okay?
You don't have to type a subscript. Oh, wait. You haven't written down the problem.
I think it was log base 6 of...
I mean, no.
No,
common log of the
log of
sixth
6th
root
root.
of x over z. Oh, oops. There.
The first thing we need to do, whenever you're working with logarithms and you have a radical, write it without that radical. Write it as an exponent. What did we say a 6th root is? Like up here, the 7th root is a 1/7.
It'll be 1/6.
Yeah, the 6th root is a 1/6 exponent, but be careful.
Do it on both top and bottom.
Yeah, both of these numbers, or letters, are under the radical sign. So you've got to put the 1/6 on the z also. Do y'all see that? And now is it something you can do?
Yes.
Just write out the answer?
It's 1/6 log x, not base x,
Mm-hmm.
minus 1/6 log z.
Well said. 1/6 log x minus 1/6 log z.
I remember years ago in the 90s, I attended this workshop, and the person, basically, here's what it amounted to. I should always, when teaching, I should always box my, circle or box my answers. It was pop psychology. It let the student know you're through with that problem and you're ready to go on. So when Tony doesn't box his or circle his answers, I have to go do it for him.
Even though it takes up paper.
What a waste of time that was, I must confess.
What a waste of time.
So that's 1/6. Get out of the denominator, and notice I'm typing the lowercase L-O. Here goes when I hit the G. Look at that bolded so nicely. X minus 1/6. Get out of the denominator. L-O-G-Z. I love common logs and natural logs because you don't have to mess with that subscript button down there.
I do kind of have a question about, like, these problems of, like, just one of my just random curious questions. What if you do, like, kind of switch it, like, will it still say you're correct if you do negative 1/6 log z plus 1/6 log x?
It might count.
Let's see.
Oh.
Let's see. Okay, I'm going to say negative 1/5 log z plus 1/5 log.
No, that's going to say wrong.
That's
there.
going to say wrong there. Log x.
Z. Oh, yes. Okay, yeah.
Yeah,
Okay.
because it's just one of those things of, like, can you do it out of order, or does it have to be, like, positive then negative?
Personally, I'd like it if they didn't accept it.
But
Let's see. I bet they will. Yes.
Yeah, okay.
I'd rather they keep
Okay.
the ones. If
Number
there's one
8.
with a positive coefficient, I think that should go first.
It's also
Okay.
easier to type because you don't have to, like, press multiple buttons to get a negative.
Oh, gosh. It's log base D. So you got to be typing in that D.
This is easy. I could just do it without
Uh-huh.
to write it down.
The one thing I'm going to write out on this one, I'm going to replace the square root with what?
1/2. So it equals 1/2 log base.
Hey, you know what I want to do?
What?
Click view an example. If you're a view an example kind of person,
You better get ready because there's going to be plenty of.
example.
Let's get started.
7 parts. Yay.
As we go along, talking and
You're breaking it up. And this is some of that stuff that my brother figured out and told me years ago. It's easier not showing a million steps. Okay?
Cool, look at it. It's
Okay.
one-
So let's, I'm gonna,
1/2 log base.
okay.
here goes.
The one step you got to do before you start typing in your answer on this one is to replace that red square root with a red what?
1/2.
Yeah. You got to have that 1/2. You'll be able to impress people with your ability to manipulate logarithms.
Yeah.
So you separate them at multiplication and division.
So how many logarithms are we going to have in this expansion?
Correct.
3. I agree.
So, do you want me to write it out, or you want to just type it out?
Write it out.
Okay. Start off 1/2
1/2 log base dx plus
plus
6 log base dy minus 4 log base dz.
Okay. Are y'all caught up with me?
Any questions there? Heather over there, any questions? No? Can you hear us? I forgot to put on the microphone. Well, Tony forgot to put on the microphone. We can't use two, although they insist. Oh, yes, we can. I don't know. Okay.
Wait, come back.
Oh, no.
Oh, here. Go back.
That's why I don't just type it in. 3 times, so that's nice. Okay.
You ready? I'm going to start typing in 1/2, get out of the denominator, log base D of x plus 6 log base D of y minus 4 log base D of z.
So how are you able to do like the log base thing without touching the...
Oh, you notice that? There's a key shortcut. For an exponent, it's shift up. For a subscript, it's shift down arrow. So shift up arrow does an exponent. Shift down arrow puts it in the subscript position.
Okay, I was just wondering because I see you do it sometimes and I'm just like, how?
Oh, you should have asked me before that. So many people just want to do the hot button, but there is a keystroke sequence that makes it, to me, it's a little quicker. Oh my
wow.
goodness.
Okay. And this one, this is a doozy.
Oh, it does.
Okay.
The first thing I do,
that's an L-N, not an I-N. Let me write it down.
I wouldn't even write that problem down the way it's written, Tony, because I see a radical, I get rid of that radical immediately. You like to skip the steps, and I like to show them, but that's one of the things. I don't even write the problem down the way it's written. That square root of x squared plus 9, I write it as x squared plus 9 to what power?
1/2.
1/2.
And that's how I'm writing it. All over. Just an x plus 9?
Quantity squared.
Oh, squared. Okay. So, wait. Instead of the square root, I wrote the square root as a 1/2 exponent. Now, we separate these things at multiplication and division, not at addition and subtraction.
This looks like an m plus n and m plus n. Remember, what did I say? You cannot split up a sum or difference.
This is going to break up into 3 logarithms. 1, 2, 3. We can't split up that x squared plus 9. We can't split up that x plus 9. There's only going to be 3 logarithms. And
y'all think y'all can go directly to calling it out for me? Or do you want them to write it out?
in place of that square root, you put a 1/2. It'll look better. Well,
Oh, you better go ahead and write it out, Tony.
I'm doing the x to the 5th. It's 5 ln x, then a plus.
Because x squared plus 9 is on top, so it's preceded by, the logarithm's preceded by a plus.
There's an exponent here at the end. Sometimes students will say, well, what about that exponent? It's only the exponent at the end that you put in front of the letter L. So I'll put 1/2 ln x squared plus 9. That has to all stay together. You can't separate at addition or subtraction.
And you must enclose the x squared plus 9 in parentheses. If you don't enclose it in parentheses, my lab will correctly assume the only thing you want to take the log of is x squared. If it's a sum or difference, it must be enclosed in parentheses.
Oh, I should have lifted that up a little. My minus,
that's okay.
That's a minus there, not a dash.
Any questions on our logic there? You cannot separate sums and differences.
Okay. Let me know when you're ready for us to type it in.
I'm assuming I can type it in. 5. Notice it's a lowercase l. I'm about to type the N. There it is.
If you put a capital I in, it's not going to bold, and
it's going to count it wrong. And then 1/2. Get out of that denominator, ln. You have to enclose the x squared plus 9 in parentheses. And then we have a minus 2 ln. Hey, maybe I'm just lying to you. Maybe we don't need parentheses. What do you think? You think they're going to count that right? Maybe I'm just telling you a fib. Let's check it. Let's suppose we don't enclose that x plus 9 in parentheses. That's incorrect, and it doesn't give you that much to help you figure out what's wrong. If it's a sum or difference in the argument of the logarithm, that's the thing that follows the log notation, you must enclose it in parentheses. Any questions there? Now we're going to start going backwards. They want us to write this as it's a difference of two logarithms. They want us to write it as a single logarithm. And really, there's no work. You go straight to the final answer. I type my log.
We're now going backwards.
And my base is an 8.
Now, will there be a fraction bar
in this argument? Do I need a fraction bar? Yes, because of what? Okay, that minus right there. So we have a fraction. What goes on top? The 12, I agree. Anything else on top?
No.
What about on bottom? 7. Any questions there?
Oh, okay. But it looks like, if it looks like, oh, well, he's just typing in the answer, there's no work to show. If you want to show some work, I have a feeling that the view and example has a lot of steps to it, okay? But that's not the easiest way to do. I'm always tempted to turn off the view and example for things like this, but I could do it, but I'm not going to. Okay, yes, I did it. Okay.
I'm typing in the same instructions, write it as a single logarithm. I'm going to type in the log and the subscript of 6. That's a 6, not a b. Will I need a fraction bar in my expansion? Will I need a... Yes, because of what? Yeah. Okay, now I want to ask you something. I agree we need one, but what minus says we need it? This first minus or the second minus? One of those minuses is the reason we have a fraction bar. The first one, I agree.
One in front of the letter L. So up on top,
that 7 is positive. That means this z goes on top, and the 7 is what? Okay, it's an exponent. Down on the bottom, that parentheses z minus 7. And this is the only time that you can have a z minus 7 and not put the parentheses, and they would accept it because it's all there together in a denominator. I still like to put the parentheses around it. Any questions there?
There's not a lot of steps to it. My best friend used to be a butcher, and he would talk about the two different types of work as a butcher. There's the work up here where they're pricing it and so forth. And then there's the physical work when they're unloading the truck and cutting the meat and stuff. This is the work up here. No physical work. You don't have to scribble to get an answer on number 11. Oh, wow, Tim. Let's see. What about this one? Are we going to have to write out a lot on this one, or do we type in the answer?
Here they're using that phrase, condense the logarithms, okay? Condense means you're taking multiple logarithms and writing it as one logarithm. They even then go on to say write it as a single logarithm in case you forgot what condense means. But I'll type my log. Will I need a fraction bar? Yes. Am I going to have any exponents? No, because there are no coefficients in front of the logarithms. No coefficients, so no exponents. What will we have on top? The 4x plus 5, I agree. Anything else on top? On bottom? Just the x. Any questions there? Oh, Lord.
Jim, I'm tired of your instructor tips.
Did I put those? I thought you put them.
Oh, well, maybe I did.
Oh,
Okay.
okay. I think it was me.
Okay. This one I think I'm going to write down.
Okay, here.
It's 1/6 ln x plus ln y.
Okay, here goes.
We're going to write it as just one of those ln's. And
do I need a fraction bar right here? Do I need a fraction bar? No, because minus.
If this plus had been a minus, then you'd put a fraction bar. But there is no fraction bar. So, what am I going to write? Okay, so the x has the exponent of 1/6 on it, and then the y. I'm pretty sure that Pearson will take it like that, but I think the way they really want you to write it,
the exponent of 1/6 is the same thing as what?
This 1/6, that's a, no. How about a 6th root? It's a 6th root.
Recall where the properties are.
Right here.
Right here.
1 over n power is the nth root, so a 1 over 6 power is a 6th root. But, actually I'm not sure why I'm writing it like that. I'm almost sure they'll take it just like this.
What do you want me to type in? You want me to type it in with the 1/6?
I want you to type it in with the 1/6.
Okay.
And you can put this in parentheses or not.
But as long as it's multiplication, you don't have to have the parentheses. You have to have the parentheses if there's a plus or minus in it. But if it's all multiplied, you don't have to have it. I think it looks better with the parentheses. What do y'all want? You want me to type it in and see if they take it? I'm pretty sure they take it right there at x to the 1/6. Let's do that.
I'm going to do it like that because if they're taking a test, I think that's the best.
ln x to the 1/6. ln x to the 1/6.
Oh.
And y. That looks
I like
funny.
the parentheses around.
Oh, you like the parentheses? Okay. Oh, I'm taking the log there.
There. Okay, now flip back.
Let's check and make sure they take it like this.
Yeah.
And yes, they do. So hold on.
So we typed in this answer.
I'd mark that one out.
Yeah. Yeah, we don't need it written like that.
Any questions there? No minuses, so no fraction in the arguments are not being divided. Number 14.
Is this one that needs any work, or do you just type it in? No? Yeah,
I
just
think we can
type it in.
Here goes. I type log base B, get out of that subscript. What will I have first?
Is there going to be a fraction bar?
Oh, I should have asked that. No.
Okay.
So that means x and z are going to be multiplied. Where does the 9 go? The exponent on the x. What about the 7? Where does it go? Exponent on the z. I agree. Just keeps getting easier and easier, doesn't it? I'd take out those instructor tips if students would stop emailing us about
the instructor tip only shows the first time you click on the problem.
If you go back and click on it again, it doesn't show.
And you got to click down here where it says view instructor tip. You can always see it there. And now with hindsight, I think I do remember typing up all those hints, thinking surely by the time the students have gotten through this assignment with those hints, we won't get the emails about
We still get
eyes.
them.
We still get them.
Okay, I typed my L in. Will I need a fraction bar? Yes, okay. Because of that minus right there. What do we have on top? X plus 7. Is there an exponent on that x plus 7? Yes. And remember I said if it's a plus or minus, enclose it in parentheses. X plus 7 to the 9th power. On the bottom, x to the 4th power. I agree.
Could you have seen yourself doing this yesterday at this time? You know, it's really not hard. Unless you do view an example. How many steps do they do on it?
That's on this one or the one?
The one.
This one.
Oh,
They remind you, and then they get.
Yeah, there's
they only
3.
do 3 parts here.
Yeah.
What is this? Oh, they're breaking it into pieces.
Oh.
Okay.
Mm.
Okay.
Okay. Well, close that. Go ahead and do the next one.
Yeah, this is one of those times I would not view an example. I'll type in my L in. Don't you like these natural logs? Only 2 letters.
No
You don't have a
subscript.
subscript. Am I going to need a fraction bar? Yes, because of the...
Minus
Okay, what have I got on top? Call it out as if I were
6 exponent x exponent 6
x exponent 6. So we have x to the 6.
plus y to the
Oh,
You just said
you-
the common mistake. You said plus. No.
No.
Okay. It's just time.
Times, so y raised to the 4th.
And we pounced on that because if it had been a plus, it couldn't have been separated.
If you're going to write a plus, those things have to be enclosed in parentheses. Like this one over. Oh, 5. Yeah, you sure you want? Yeah. Okay. You see, if you're transferring over a plus, it has to be enclosed in parentheses in the original problem. So back over here,
I'm used to doing it the other way.
and what have we got on the bottom?
Z to the 2nd power.
Okay, z
Square root.
square, not square root.
Square.
And I want to point out something before I check it. Suppose we had put that plus. Maybe we're lying to you. Maybe they'll accept it. Let's see. No.
Why? Because that statement, switch over here, Tim. Where did I say? Oh,
Wait, hold on. Let me find it.
You separate logarithms at multiplication and division, not at addition or subtraction. So go back to that. If you had the plus up there on top, the x and the y couldn't have been separated. You only separate at multiplication and division. Have you checked it? Now to make sure they... Okay. Okay, we finally stopped we get to something new. Number 17 might be the hardest problem we've done so far. Use a calculator. Okay.
Well, you are joking.
I am
right?
joking.
Oh, okay.
Yeah, very much so.
I thought maybe you had some different technique that was going to make it real hard. I was like, Tony.
Your calculator, if it's like mine, the one that we have up here, there's only 2 logarithm keys. The log base 10 and the ln. We're going to, here, you're just using the log base 10. You hit log.
Notice it opened a parentheses for you. So even though there's no parentheses around that 69, type in the 69 and then make a habit. If you have a parentheses open, you need to close that parentheses because we're going to get some really messy stuff in the next assignment to be punching in. And if you're not closing the parentheses when they're open, you are going to get dramatically wrong answers, okay?
I know a lot of students have got the Calc 84 calculator on their phone that we showed y'all at the beginning. Can you switch
over
here?
And once again, if you're using your phone calculator, you need to show that, to hold it, and you're taking your test at home. 69. You need to hold that up to the video camera and show and say, I am using my phone calculator. It's 69.
69. I keep hitting. What is wrong with me?
Clear all
let me
that
see.
and start
Clear. 69. Wow.
You found an error, and there's a bug in that.
Let me try it again. Log 69. Okay. I guess my hand's just hitting it wrong.
Clumsy fingers.
And we're getting the same answers? Yeah.
Well, this one, the phone
one has more
digits.
It's more precise than that old calculator there. So type in 1.8. How are you told to round it?
I don't know. That's something to look at and see. Round to 4 decimal places. So 1.838. Is it going to be an 8 or is it going to go up to 9?
8 because it's not 5 or more.
That's right. We use traditional rules of rounding.
I'm thinking this might be the first time this semester we've actually rounded decimal numbers.
Yeah, I think so.
Let's see.
Okay. Now. Okay.
Notice most calculators only have log and ln. Most calculators don't have a log base 4 key on them. So if you're trying to evaluate a logarithm and it's something other than log and ln, we have a formula called the change of base formula.
Log base b of x equals, which one do you want to use? ln x over ln b.
Or you could say
ln x over ln b.
it could be common log x over common log b, but
it's more commonly stated with the ln, and so you think, oh wow, it's gotten hard. No, it isn't. Okay.
Write the problem down, Tony.
I haven't written down the problem.
I told you, write it down.
This is number
18.
18.
Log base 4 of 13. So you're asking yourself, 4 to what power gives you 13? Well, 4 to the first is 4. 4 squared is 16. So we skipped right over 13, didn't we? So
it's going to be 1 point something.
It's not going to be a rational number. It's not going to be a rational number.
Okay. There's log base 4 of 13.
It's log
You write it.
It's ln 4 over ln.
Wait, which one goes on top? And
4 goes on the bottom.
okay, the number that's written lower is the one that goes on the bottom. Okay? So it's this that you're going to have to type into your calculator. That's what the change of base formula says. But you've got to be careful.
It opened a parenthesis. You have to put the 13 and close the parenthesis.
When it opens the parentheses, you've got to close them.
Divided by ln. It opened a parenthesis. We put the 4. Now, the very final parenthesis, if you don't close it, they close it automatically. But we had a lot of experience programming. We minored in computer programming, and we know the dangers of dangling parentheses. I would never open a parenthesis without closing it. So,
Let's see. Oh, how would they say to round it? 4
Let's see.
digits?
1.8502.
yeah, it's another 4
4
digits.
So 1.85
1.0.
0. Is it going to stay a 2 or become a 3?
It's a 2 because it's a 1 right behind it.
Yep.
That's correct.
This is the traditional rules of rounding, which says,
Oh, I have a fun idea. Suppose, maybe I'm just lying to you. Maybe you don't have to close those parentheses. If you'd gone ln 13 divided by ln 4, do you think you're going to get the correct answer? Let's see. No, nowhere near.
okay.
Any questions there? Oh, another one.
Same type of problem. Log
Base 4.
4.
again. That base could be any positive number other than 1, so it's just a coincidence that 18 and 19 had subscripts of 4. So
Oh, I hadn't even noticed that. So it's going to be ln over ln. Which number goes on top and which number goes on bottom?
Which number you're going to write here beside the top ln? Okay, the 0.06.
The number that's written down lower, that subscript, that's the number that goes on the bottom.
So we have
Watch the parentheses. I'll go ahead and put them in.
0.06 close parentheses divided by ln 4 close parenthesis. And let's see, how do they want us to round this? They want us, let's see, what did they say?
Okay, it's 4 decimal
again.
places.
So a negative,
0.0294.
Oh,
a
okay, so-
negative 2 point.
The negative.
Yeah, there's a negative. Is it not showing on the display?
No, it's a small.
Did that thing come down? Is it working correctly?
Yeah, I think that.
No, I lowered it manually.
Oh, okay. So we're going to have to hook in a 0.2. Okay, what did you say? Is that going to stay a 9.4? I agree. How
And
long?
finally, the last problem, it has to be the hardest.
This one is one that's sort of.
Well, okay. We need a new rule to do number 20. Hold on. Tim, let me write this rule down. If you have that number E, the 2.718281828 number, E and ln, when they're right side by side with nothing between them, cancel each other out. We could say formally the exponential function E and the natural logarithm function are what? What are those things called that cancel each other out? Inverses. Good. Here's another way it might be written. if the ln had been written first and then an e to the x, they cancel each other out.
And this goes back to an earlier property that he stated in terms of logarithms, in terms of base b. This is just a specific case for this thing here. Remember, log base e, that's denoted ln. So ln e to the x equals x, and e to the ln x equals x.
In other words, if e and ln are side by side with nothing between them, then they cancel each other out. Number 20 is not as hard as it looks. It's not hard at all, as long as you know about this canceling stuff here among e and ln.
F of x is equal to the natural log of x.
Okay. F of x equals ln x, part A.
Why don't you write all three parts down, and then I'll switch over to the paper.
Oh, okay. Find f of, what is that, e
To the negative 6. And then part b.
I think I'll do it like this. B says find f of
E to the ln 6.
And finally part C,
F
of
e to the 2 ln 6.
e to the 2 ln 6. Okay.
Okay, here we are at the paper.
Okay, I'll maybe move that calculator.
We're not using that
We're through with that calculator today, aren't we?
Uh-huh.
Okay. With function notation, whatever's in the parentheses, you plug in for x. So in part A, in place of that x, I'm going to put a e to the negative 6th. So I had the blue ln, and in place of the x, I'm putting this stuff right there, e to the negative 6th.
What's that going to reduce to?
You have the ln and e,
-6.
they cancel. Here we just have a negative 6 as the answer on part A. Okay? We'll wait to type in all of the answers at once. So y'all are just going to have to trust me for a moment that these are right.
Part B.
Okay. In place of the blue x, I'm going to put what's in the parentheses here. That's the e, the black e to the ln 6. So in place of that blue x, I have the blue ln.
So it equals 6.
Let me see. I have the blue ln, and then I have all of this stuff. The black e and the black ln 6. I think there's a little bit more to it.
There's a one-to-one correspondence when you're canceling out these inverse functions. We have ln e, that could cancel out, leaving us with what? ln 6, or right here, the black ink, e to the ln. E to the ln could cancel out. I would have that blue ln and what? A 6. So either way, you're left with an ln and the 6.
I think I'm going to cancel just the blue ln and the black e.
You don't go into a cancellation frenzy. Some people see e's and ln's together, and they literally just go into a cancellation frenzy, canceling everything. No, it's a one-to-one correspondence. You either cancel one ln and e, or one e and ln, but either way,
You don't cancel both.
And remember, they've got to be consecutive. To cancel them out, they got to be consecutive.
There can't be anything between them, and the next one's going to illustrate that.
Part C. We're going to go to that ln x, and we're going to replace the x with that red e to the 2 ln 6.
So we have a blue ln, then I'll write the red e to the 2 ln 6. On the previous problem, you had a choice. You could cancel the black E and the black ln, or you could cancel the blue ln and the black E. You'd still get the answer, same answer. Here, there's only one way to cancel.
What is it? Can I cancel the red E with the red ln? No, because they're not consecutive.
There's something between them, the two.
So what can you cancel? Okay, ln E you cancel out, and you're left with a 2 ln 6. For my final answer. Yes.
So you got 2 ln 6. Why wouldn't that go up factor down to ln 6 to the second?
Oh, perfect. Oh, wow.
Yes, you can. Yeah,
You
okay.
hear that?
You've mastered it.
You could certainly write it as ln 6 squared, and if you're going to do that, you may as well replace the 6 squared with
36.
36. You
So-
see? Yes.
Did y'all hear that question?
Okay, bring this 2 up as an exponent. Wow.
And if you do that, I'm pretty sure they're going to want you then to write it as ln 36.
Uh-huh. That would be the best answer.
That's the best, in my opinion, ln 36 is the
But,
best answer possible.
but for this, Pearson, for this particular problem, you can just stop at 2 ln 6.
I remember there was a multiple choice problem years ago in the test bank, and they left it at this point. The answer they wanted had the number in front of the ln 6. So we just stopped there, but I bet you they'd take out of one of them.
Well, I'm afraid if we type in ln 36, then...
Negative 6.
Negative 6.
And ln 6. ln 6.
Again, don't hit capital I. You may not be doing this assignment for weeks if you're gotten a little behind. Okay, fine. But
this assignment isn't due for quite a while. But you notice it took the 2 ln 6.
Mm-hmm.
But it would have taken ln 36 also.
Uh-huh.
Any questions?
Oh,
there?
wow, this is one of those times when I hate to ask any questions, but I guess we've got to. It's a big day, a huge assignment.
This is
Most
a big
people
day.
have never worked with logarithms. Most people in this class have never worked with logarithms, and we just did a heck of a lot. Okay?
Okay, I'm going to stop recording.